Hi, so this is the actual Labrador device, as you can see. So what I'm gonna do is hold this thing towards this side, because that way I can understand what's going on. So like I discussed before, the pin configurations, this particular pin, it's going to be ground, as you can see in the diagram, and this pin is going to be the power supply. So as you can see on the breadboard, so if I can place it like this, that means that the negative side will be shorted with this one and the positive side will be shorted with this one. I'm just doing this for a better convenience. But the thing is that it's a bit challenging to connect this over here, because the pins, they actually contradict. This is like it just gets over here. So what I'm gonna do is like bend the pins a bit so that it just goes inside of it, and that way it would be you know easier for us to set it on the breadboard. And I'm just going to show how I do it. So it's already a bit bent on this side, which is towards this side. So I'm just going to place it over here so you can see. So the negative is this one and the positive is this one. So I'm gonna place this first to make sure that this is okay, and then carefully see that if it fits, and I'll just press it just like this. This is how you set the Labrador to the breadboard. That's the first step that we have to do. Then in the next step, I'm just going to be connecting this Labrador with my PC. So you can also connect it with Linux or other device or Mac, like I've said before. But I'm just going to show it for Windows. Because it's the most common interface that everybody uses. So what I'm gonna do is, like, I have the USB-B port that actually goes with it. So before I do that, there's a couple of things I want to mention. So the reason why I made this connection over here and this over here is because, as we all know, the breadboard is shorted just like this. It's kind of like vertical. So if I shorted it, for example, these two pins over here and these also over here, there's a very high chance that these two are going to be shorted. So you can either connect this over here and this over here, like I said before, or this two over here and this lines just over here. But I just did this because of the convenience, because it's already marked that this is the negative end, this is the positive end, just like the way the Labrador pin configuration is set. So that's how I'm gonna do it. And after you just connect this one just like this, a red light is just gonna pop up. So that's how you actually connect it over here. So I just connected the USB port to my PC after connecting the other port to the Labrador, and what it's going to do is, first it's going to ask me to calibrate. As you can see in the manual, it asks me to calibrate. So there are two things you have to calibrate. The first thing is you have to calibrate the oscilloscope. So here I would just like to press yes, go ahead, and this is the thing that's going to pop up again. It's going to show the calibration sequence, and requires all the devices to be turned off and everything except for the oscilloscope channel 1 and 2, and that's the thing that I have to calibrate first. So I'm gonna just press OK, and then everything is disconnect all the wires from your Labrador, press OK, and that's the thing. So connect both the oscilloscope channels to the outer shield of the USB connector and then press OK to continue. So what I'm gonna do is, so as you can see over here, so this is the thing, so this is the oscilloscope channel 2 DC, and you can also calibrate this one, but these two are duplicates. So I'm gonna just go with this one, and I'm gonna go, so this is the channel 1 DC line of the oscilloscope. So these two lines, actually a wire from this has to be connected over here, and a wire from this one will be connected over here, just like the way it mentions in figure 3, which I'm going to be doing just now. All right, so this is the port for the oscilloscope 2 DC, and this is the port for the oscilloscope 1 DC. So the oscilloscope 1 DC, just like you can see in the figure, so I'm gonna be just connecting that over there and this one over to this place. Like, you have to be careful while doing this, because you want to make sure you don't short your finger over to this side with any of the connections, because you don't want to get this, you know, like the electric, you don't want to fill the current. So also this one, this is the channel 2 for the oscilloscope, and I am just gonna make it in a way so that it connects over here, and that's how it's done actually. And then I'm gonna be seeing in the oscilloscope like how it turns out on the PC monitor. Right, now that I have connected those two things just like it suggests, so I'm just gonna go and press OK, and then let's see, it shows that the oscilloscope calibration is complete. And then now comes the power supply calibration. So I just have to keep following the instruction that pops up on the screen. So it just says that it requires me to control your power supply temporarily. So to prevent blue smoke damage, disconnect any circuit attached to your power supply right now. At the moment, if you remember, like I just have 2 oscilloscope ports are connected over there, and there are no ports coming out of the power supply. So that's something that you have to ensure first, and then press OK. And what's going to happen is, please connect your oscilloscope channel 1 DC pin to the power supply output, and then press OK to continue. So I'm going to do that and then get back to the screen again. All right, so now that it asked me to connect my oscilloscope channel 1 DC pin to the power supply output, that's exactly what I'm going to do. So I just remove the channel 2 DC pin because I just want to make sure that nothing is shorted. So what I'm going to do is I just took this one off from here, and then I have to connect it to the power supply output. Always I would like to suggest you make sure which pin is the power supply output, whatever pin you are going to use, because you have to double check with the manual. And I just set it in a way that, you know, it just matches the diagram that I showed before. It's always better to, you know, have it printed so that you don't have to look back and forth to it. It's just going to be over here, and then you can connect. So because of the red light, you might not see it properly, but the reason why, like I said before, placed it just like this is because for my understanding, better understanding, because this positive short, it's on the left side of this pin, and the negative port is over here, which is the ground. So this is basically the power supply output. So if I point it out, this is gonna be this pin over here, not anything over here, just this pin, and the one just by this red light. So I'm just gonna take this over here. I just double checked which one is my power supply output, and then I will just make sure that it gets connected. So when it gets connected, you're not gonna see anything on oscilloscope before you press OK. So you just make sure you connect it, and the way you're gonna understand is on the oscilloscope, if it's not properly connected, it's gonna, you know, like show some horizontal line, but if it's properly connected, then it's gonna show nothing actually. So after that, I'm gonna go back to the screen and show you how it actually looks like over there. So now that I connected my oscilloscope channel 1 DC to the power supply output, like I was saying, it's not gonna show anything on the screen. So no mark, as you can see, anything on the screen. So what I'm gonna do is press OK. And I guess it's gonna, yeah, so it shows up PSU calibration complete. So I'm gonna just go with OK. And I guess that would be all for the calibration. All right, so now I'm going to be showing how we will use the Labrador to measure the voltage. As I have already discussed, there is a channel 1 and the channel 2 for the oscilloscope. So before I do that, one thing is I have to mention is that here our resistor is the load. What I have done over here is just construct a simple circuit, which is one end of the load is connected to the positive end, and another end of the load is connected to the ground. So that's what I just did over here. And now I guess we already know the fact that in order to measure a voltage across a load, we have to connect the oscilloscopes in a way so that it's parallel with the load. That means one channel of the oscilloscope is connected to this one, and the other channel of the oscilloscope is connected to this one. And after we do that, we can actually measure what's the voltage across it. So now that's what I'm going to be doing. As you can see, I'm just connecting one channel to the positive end, right? And then I have got another channel that I have to connect across the resistor, which is just over here. And after I do that, I will be seeing what's my voltage across my load. Back to the screen after the circuit placement. So as you can see over here, there are two lines. The blue line represents the oscilloscope channel 2 and the yellow light represents the oscilloscope channel 1. As you have seen that while constructing the circuit, I placed the probe 1 of the the channel 1 of the oscilloscope to the positive end of the resistor, and the grounded portion of the resistor was connected to the channel 2 of the oscilloscope. So basically you can see the difference in between them because I have to add a reference. So if I add a horizontal cursor over to the yellow line, then you can see the voltage is actually 4.73 volts. All right, so for voltage measurement, we placed the channels of the oscilloscope from the Labrador in a way so that they are in parallel with the load. But in order to measure the currents, we have to do it in a way so that there is a discontinuity first, and then one channel would go over here, another channel would go over here. It would make the ammeter, like the ammeter would actually continue the circuit, as you can see over here. So that's the way you measure the current with the help of an ammeter. But what happens while measuring the current with the help of a Labrador? So what we just do here is just just connecting the oscilloscope probes at this two end. The manual suggests us that if we have a load of value R, then the oscilloscope channels need to be connected in a way so that it's also in parallel with a value of a resistance, and that value of the resistance would be 10% of the load that you connected over here. I don't know why they do it, but it's just the way it is. So for example, like if I use 1 kilo ohm resistor over here, then you divide it by 10, which is the 100 ohm resistor that has to be connected in series over here. You don't have to worry, I'm just gonna show it over to you just after I go through this. So for my case, what happened is I already told you my resistor is around 9.87 987 ohms. So the typical value of the resistor over here would be 98.7 ohm, right? So the manual shows that you have to use a potentiometer in order to apply that, but since we don't have a potentiometer with us, so what we are going to do is just construct a resistor. Like I have over here, as you can see, a 50 ohm resistor, another 50 ohm resistor. Both of them are connected in series. Like this one end is not connected with anything. These two ends are shorted because this two in together makes one resistor of around 100 ohms. And over here I have 9.87 ohms. So what I'm going to do is like connect the circuit and show it to you how to connect it, right? So like I said, this circuit cannot be complete. The oscilloscope channels would complete the circuit first. That's the number one thing. And number two thing is that oscilloscope channels are going to be in parallel with this resistance. So how I am going to do that? So as you can see, I already took out the negative, the grounded portion of this resistor, because the ground has to be connected with one oscilloscope channel and another oscilloscope channel would be connected to the other end of the resistor. That would actually complete the circuit. That's how you actually make the current measurements, right? So now what I'm going to do is, so see, this is oscilloscope channel 1. This oscilloscope channel 1, I would just place it across this end of the resistor over here. So I just made it like this. And then I'm going to be taking another wire. This is oscilloscope channel 2. And I would place it on the ground over here. And this is actually completing the circuit, okay? But like I said, we have to also make a parallel connection. So the duplicate channel of this oscilloscope channel 1 is the last pin across this row, which is over here. And this is something I'm going to be connecting to one end of this, 100 ohm resistor, and another end of this 100 ohm resistor is gonna go over here. Okay, so that's how now the circuit is complete. So we are gonna move over to the screen and see like how to measure this current over there. Okay. Right, so I use the oscilloscope channel 1 and the channel 2 for the voltage measurement, and now we have to see the value of the current that we are measuring. So what I have to do is first uncheck these options, because I'm going to be using the multimeter to calculate the current, right? So I check this option, made sure the mode is current. All right, now I have to measure. So still it doesn't show the value of the current. The reason is the value of the resistor that I connected in parallel with the oscilloscope channel 1 and 2, which is 10% of the load resistance value, that is something that I have to give as an input manually. This is something the machine does not read automatically. So I measured that value to be around 93 ohms based on the value, based on the reading that I took with the help of my potentiometer separately. And that is something when I give as an input and press enter, you are gonna see this is the value. This is sometimes fluctuating. This is okay, no problem. You just pause it. But this is the value that we are supposed to get based on the resistor combination that I gave, right? So my resistor value was around 987 ohms. And if I apply 4.5 volts, so 4.5 divided by 985, that value actually falls within this region. So the maximum current that can pass through that resistor, that is 5.72 milliamps, and the minimum is 4.81. So the value is going to be in between, right? So this is how you can justify or take the current reading with the help of a Labrador kit. All right, so now what about the value of the resistance? So remember, this is something I'm doing at last, but this is something you had to do at first, okay? But you can do it at the end of the, when you are done measuring the voltage or current, it doesn't matter. So you just set your potentiometer over here, because we know that the value of the resistor that I am using, that's around, 987 ohms. So the value that I'm going to read, that has to be lower than the the marker that where I'm setting my potentiometer to. So now over here it's around 2000 ohms. So obviously the resistor value, I know it's going to be within that range. So when I measured this value, it's actually, you can see, around 987 like I mentioned before. And when you actually try to measure the resistance for connecting across the channel 1 and 2 of the oscilloscope, that value would be 94 ohms. So 94 ohms is the value you had to give as an input to the series resistance. Remember, when your circuit is connected totally while measuring the current, at that time if you take the value of the resistances, then that's not going to be something, that's not going to give you the correct value. So this is something you have to do at first, or you can do at last, no matter what. So this is how you can actually take the value of the resistances. So now that we have seen how to take the voltage measurement, how to take the current measurement with the help of Labrador and the resistance value, this is something that you can just do it separately, just trying not to be a drag about this. But yeah, this is how you actually perform the measurements of voltage, current, and the resistance. So that was about it about the Lab Zero. I hope you learned whatever the process that I went through. But still, if you have any questions, I am obviously going to be in the lab session, so you can just ask me any questions you have. I would be happy to help. Thank you.